So let's start with our trig functions, okay? Do you guys remember, is a tangent function even or odd? It is odd. And what does odd mean again? Odd means if I plug in negative x, I will always get its opposite, right? Odd means you will always get that opposite. So like when we looked at one of the quizzes last time, it said sine was 0.8. And it said, what is sine of negative x? Sine is also odd. So if the regular sine was 0.8, its negative would be negative 0.08, okay? So that's all that one was looking for, all right? So the graph of y equals tangent of x is going to be symmetric with respect to the origin. And what symmetric means? It's the same on both sides, right? Okay, it's the same on both sides. Now, real quick, as we think of tangent, how do we find tangent? There's two ways, either our trig identities or looking at our coordinates on a coordinate plane, right? How do we remember tangent? Tangent of x is equal to what? Tangent of x equal to? Or tangent of theta, we can look at it as theta. Isn't it the same thing as y over x? Or if we look at our trig identities, the sine of theta over the cosine of theta, or sine of x over cosine of x. And if you notice, because we have these fractions here, what can't x equal, or the cosine of x equal? 0, right? So x can't equal 0, or the cosine of x can't equal 0, right? And if that can't happen, can we have certain coordinates on my tangent graph? No. So if you notice, when we look at this graph of a tangent function, we have all these dotted lines. What are these dotted lines known as? Asymptotes. Those are your vertical asymptotes. Okay. So with tangent functions, we're going to have those vertical asymptotes when the cosine is equal to x. Right? And when we look at that, the cosine of what is always equal to 0? And that pi over 2. We're looking at 3 pi over 2. We're looking at 5 pi over 2. And then we're looking at negative pi over 2, right? And so on in each direction there, okay? You can't see all that. Now, if we look at this, our period from negative pi over 2 to pi over 2 covers how much? 1 pi, right? 1 pi. So the period of a tangent curve is pi. The domain represents all x values, right? But is every x value on my graph? No, because we have these vertical asymptotes, correct? So our domain is actually all reals except x cannot equal pi over 2 plus n times pi, okay? And all that means, if you notice, we start at pi over 2, and then we add in a pi every single time is what that is. The n just represents an integer. So if we are going negative 1 pi, that would give us at negative pi over 2. If we go a negative 2 pi's from that pi over 2, that would give me a negative 3 pi over 2. Okay, so that's what that represents here. What is my range? My range is the y values. And is there any y value I can never have? No. So that's going to go from negative infinity to positive infinity. And again, we have all our vertical asymptotes when our cosine is equal to 0, right? So which isn't that the same thing as my domain part? So my vertical asymptotes is x equals pi over 2 plus n times pi. Okay. So again, that represents we start at this pi over 2, and then we add a pi every time. So that n just represents how many pi's I want to keep going from that, okay? Do we have an x-intercept? Yeah. my x-intercept is always, if you notice, we have it at 0, we have it at pi, we have it at negative pi. Where else would we have it at? With 2 pi? With 3 pi? With 4 pi? With negative 3 pi? Yeah, so the x-intercept is always n times pi, comma 0. So the first one is 0, and then we can go into 1 pi, 2 pi, 3 pi, or we can go negative from that 0. Okay. Do we have any y-intercepts? Yeah, we just have one, don't we? The origin of 0, 0. And then once again, we're symmetric around what axis? Or not axis, what are we symmetric around? Origin. So the left side of the origin is the same as the right side. And again, we have an odd function. All right. Now, this is kind of set up as like our sines and cosines here, okay? This is all based off of that parent function of just tangent of x, right? Tangent of x. If we have y equals a tangent of x over 2, what actually is changing from this? What changes? Your period. Our period changes, right? So our period now is going to be what? 2 pi divided by what? Okay, divided by 2, which is actually 1/2. Okay, which is 4 pi. Okay. Now, this is going to be a little bit different from that sense, though. Okay. So as we look at this, okay, so if that was a sine curve, to find our period, we'd have 2 pi over 2, 1/2, I'm sorry, 1/2, said 2, which would give us our 4 pi, right? So we know we'd have to go from that every single time, okay? However, when we're looking at this, we're looking at our cosines of everything, right? Because we want to know when is a cosine equal to 0, and that would give us our vertical asymptotes, correct? Yes, okay. So now, as I look at this, okay, now, when we're going through this, we're going to start with normally our first vertical asymptote is at what? Negative pi over 2. Is that correct? Our first vertical asymptote is normally at negative pi over 2. You guys okay with that? So this is where in our tangent function, this is where my first vertical asymptote is. Okay. So now, to figure out our transformation, right, we're looking at that bx minus c equals that, right? So in this sense, we're going to look at our bx is just x over 2. We don't have a minus c, right? Equals negative pi over 2. So where is my first vertical asymptote going to be? Negative pi. Okay, our first vertical asymptote is going to be at negative pi. So if I go and draw in, so normally we have a vertical asymptote at negative pi over 2. Now we actually have one at negative pi. Okay. Now, where's my next vertical asymptote is? Isn't it a positive pi over 2? So can we set x over 2 equal to a positive pi over 2? So then our first other vertical asymptote is what? Pi. Now, as we look at this, we have pi over 2, and then we have pi. We have another vertical asymptote here at pi. Now, where we messed up in our period with our sine and cosine is always 2 pi over 1/2, right? However, what is the period of a tangent function? It is just pi. Is it normally 2 pi? No. So our period for this, instead of taking 2 pi divided by 1/2, we should have just taken what? Pi over 1/2, which ends up giving me what? 2 pi, right? And let me ask you, from negative pi to positive pi, isn't that 2 pi? Yeah. So where would my next vertical asymptote go? Huh? So we went from negative pi to pi. So we're going to go to pi to 3 pi. Why is it 3 pi? Because it's plus 2 pi. Exactly. So where would it be going backwards? Negative 3 pi. Is everyone okay with that? Obviously, these aren't spaced evenly, right? I did not do a good job spacing evenly. Now, huh? No, it's not good. All right, so let's kind of think about this. All right, let's start with 0. Okay, 0's directly in the middle of negative pi and pi, right? So we know, again, that's going to be at 1. You guys okay with that? Now, what is my amplitude from this? What are we multiplying by my tangent by? What is the number in front of the tangent of x over 2? 1, right? So at pi over 2, because from 0 to pi, the middle of it is pi over 2, we know my amplitude is going to be 1. Now, how can we figure that out? Let's think about it. Tangent of pi over 2 divided by 2, right? So we have the tangent of pi over 2 divided by 2. What's pi over 2 divided by 2? Pi over 4. What is the tangent of pi over 4? Can you use your calculators for that? Yeah, you can. What's the tangent of pi over 2? Make sure you're in what degree? Radians. What is the tangent of pi over 4? 1. So do you see how I got pi over 2 comma 1? Yeah. Now, 1's the 4 at negative pi over 2. What's going to change here? It's going to be negative pi over 4. And what's the tangent of negative pi over 4? Wouldn't that be negative 1? Okay. And then we're just going to kind of do our curve where we approach the asymptotes, but do we actually cross them? No. Okay. So now, if we know between negative pi and pi is 0, what's between pi and 3 pi? 2 pi, right? So wouldn't that be an intercept at 2 pi? And wouldn't it also be an intercept at negative 2 pi? Yeah. Now, what's in the middle of pi and 2 pi? 3 pi over 2. So we know that one would be at negative 1. And between 2 pi and 3 pi would be 5 pi over 2, right? Which wouldn't that be at positive 1? And then could we get our other curve here? And same thing here, 1, negative 1. So this would be negative 3 pi over 2 and negative 5 pi over 2. There's your graph. Obviously, I know my spacing is terrible. It doesn't look right. That's it. Reno, you have a question? Okay. Okay, because if I'm plugging in 0 here, because 0 is in the middle of negative pi and pi. So if I plug in 0 here, the tangent of 0 over 2 is the tangent of 0. And what's the tangent of 0? 0. That's right. Okay. So I just didn't plug it in because I know it's directly in the middle. Also because my y-intercept is 0. We're not shifting left or right because we don't have that minus c. Okay. Does that help now? Yeah. Okay. All right, any other questions so far? All right, yes.
Okay, it's a lot to think.
It is.
Okay. No, never mind. I'll come back to it later. I don't even know what to say.
Okay. Let's try this one and see since it's another tangent function, okay? So now, looking at this one, okay? The first thing we need to do, what does this negative tell me? Just so I know, what does that negative tell me? It's a reflection, right? So what's going to happen to this? It's just going to go the other way. So at negative pi over 2, it would have been at 1, and then the other way, okay? Now, this 2 is going to change, this 2x is going to change what? My period, right? Okay, what is my period going to be? What do you think? Pi over 2, yep. Why? Because normally my period is what? Normally my period is pi, right? And then we always divide by my b, which is 2. So that's why we get that pi over 2. Okay. What is my max going to be? 3. Well, it's not really a max now in this case, but that will give us our next point, right? So 3, and the min would be negative 3. Okay. Just kind of an idea. That's where our points are going to be, and I'll show you why that is. Okay. Now, we know our period is just pi over 2. Okay. So if we look at, and we go to graph here, from 0, we need to go in both directions, and these both directions should be what? Pi over 2 together, right? So now let's think about that, okay? Normally we start at what? Negative pi over 2, right? So we're going to set this 2x equal to negative pi over 2. How do I solve for x? Divide by 2. So x would equal negative pi over 4. Does that make sense? Okay, so from 0, I'm going to go over to negative pi over 4. Does anyone know what it would be to the right now? From 0 to pi over 4 is like 25, right? So when I have to go 25 to the right, wouldn't that be a positive pi over 4? And if you don't know that, all you have to do, once you have the left side, just take off the negative, and that's your right side. So we have a vertical asymptote at pi over 4 and negative pi over 4. Now, could we go find our next vertical asymptote if we wanted to? Yeah, because what's my period? Pi over 2. What is pi over 4 plus pi over 2? So pi over 4 plus pi over 2. 3 pi over 4. So we'd have one at 3 pi over 4. So backwards would be negative 3 pi over 4. Is everyone okay with that? Okay. And then we'll split it halfway. And then we got to do quarters between those, right? You guys okay with that? Now, we know automatically we're going to have a point at 0, 0. You guys okay with that? Now, let's go to the right. We have 0 to pi over 4. What is the middle of 0 and pi over 4? What is the middle of 0 and pi over 4? Pi over, what did you say, Judy? 8. Why? You just take pi over 4 and divide by 2. And wouldn't that give you pi over 8? So then this way would be negative pi over 8. Now, 2 ways we can do this. The first way is let's just plug it in, pi over 8. So you have negative 3 times the tangent of 2 times pi over 8. What's 2 times pi over 8? Pi over 4. In your calculator, guys, what's the tangent of pi over 4? 1. And what's 1 times negative 3? Negative 3. Okay. And we know it's a reflection, so the first point to the right actually will be in the negatives, not the positives, right? So where do you think the negative pi over 8 is going to be? Positive 3. And there's your curve. So now, we know this one here is going to be at 0, 0. But what is the middle of pi over 4 and 3 pi over 4? What is the middle? Huh? Pi over 2, yeah. So at pi over 2 and negative pi over 2, we're going to be at 0, right? What's the middle of pi over 4 and pi over 2? 3 pi over 8. And at 3 pi over 8, we'll be at positive 3. So then what was the other one? 4 pi over 8? 5 pi over 8. I wrote 5. We'll be at negative 3. And here's your other one. And then same thing here. Positive 3 and negative 3. All right. And then we're just finding the middle. So since this was 3 pi over 8, this would be negative 3 pi over 8. And this would be negative 5 pi over 8. Okay. Juan, do you have a question now? Did you think of it? Yes.
So, you said this example doesn't really matter, but for your periods, how do you decide what? I know you circled it and then you pointed at the pi over 2. How did you decide that?
Oh, why I was put, okay. Because our normal tangent function is pi, right? So you always take pi or your period divided by your b, what's getting multiplied by the x. Okay. Now, so in this case, we took pi divided by 2, so that's where we got the pi over 2. In cosine and sine, it was 2 pi. That's why we use 2 pi over 2. Or 1/2, sorry, 1/2. So like the first one, we should have used pi. At first, we were talking about cosine things, so I said 2 pi. I meant to just say pi for tangents. Okay. So for your period, okay?
All right.
For a sine and cosine graph, your period is normally 2 pi. Okay? Now, when you have a b with the x, you always take 2 pi and divide it by that b. Okay? For a tangent, my period is always pi. So instead of taking 2 pi divided by b, we actually take pi divided by b. Okay. Does that make more sense?
I think so.
Yeah. So like in example 1, when I started going, I went where we were talking about sine, cosine. So I kept going with that, and I shouldn't have. I should have done pi originally.
I don't know what you mean by that.
Okay. All right. No problem. See, that's why it's crossed out. That's why it's crossed out. All right. Any questions? All right. Cotangent. Cotangent is just the reciprocal of what? Tangent, right? So again, what is going to be the period of a cotangent? The only difference with tangent and cotangent is in cotangent, now we're dividing by the sine of x. So instead of having a vertical asymptote at the cosine of x, we have it at sine. So when our sine of x equals 0, okay? So we will have a vertical asymptote when our sine is 0. And when is our sine 0? At 0, at pi, at 2 pi, at 3 pi, and so on, and going both directions, right? So cosine, we had zeros at pi over 2, 3 pi over 2, every 90 degrees. Here, we're looking at it at 180 degrees at our pi, okay? So instead of our first thing going from first vertical asymptote, our first pi, from negative pi over 2 to pi over 2, we're going from 0 to pi or 0 to negative pi. That's it, okay? So again, our period is pi for my original cotangent, okay? But again, sometimes we'd have to find it by taking pi divided by our b. That's a b. I don't know why I can't write b. B. Pi divided by b. Okay. Now our domain is going to be all reals again, except now x can't equal. Before it was like our pi over 2s. Now it's just pi's, right? So it's going to be n times pi, so however many pi's we're going out. Okay. What do you think our range is going to be again? Negative infinity to positive infinity. Our vertical asymptote is like our domain where x equals n times pi. What about my x-intercepts then? Our x-intercepts for tangent was at pi, 2 pi, 3 pi. But now those are our asymptotes. So now our x-intercepts are actually going to be at those pi over 2's. And then plus the n times pi. And again, why is that n times pi? Because after we get past the vertical asymptote, we added another pi from that pi over 2. Okay? Do we have a y-intercept cotangent? Do we have a y-intercept for my cotangent? No. Why? Because we have a vertical asymptote at x equals 0. So isn't that my y-axis? So if I have vertical axis or vertical asymptote at my y-axis, can I ever cross it? No, so meaning I can't have a y-intercept. We are still symmetric over the origin, and again, it's an odd function. So real quick, go ahead and find my period for me. So go ahead and find my period for me. It's cotangent or tangent. So normally it's always what? Pi. And then we divide by my b. What is being multiplied by x? 1/3, right? So what is pi divided by 1/3? 3 pi. So now instead of just being a pi going from 0 to pi, we're going from 0 to 3 pi. Okay? So if I look at and draw this, so we would go from 0, we would have this vertical asymptote, and I'll go over it with blue, the vertical asymptote here. And then we're going to go all the way out to 3 pi. We'll have a vertical asymptote. Where else then? Okay. Negative 3 pi. Yep, we would have another one at negative 3 pi. Where else? What would be to the right of 3 pi? 6 pi. Negative 6 pi. What else? 9 pi and negative 9 pi. Okay. Does that help? Find your periods now? Dividing it by, your x? Okay. Now, we know from 0 to 3 pi, this is going to be our cotangent from here. Okay. So again, we're going to have our x-intercept directly in the middle of these two, this period, right? So what is the exact middle of 0 to 3 pi? What is the exact middle of 0? Or think of 0 to 3. What's the middle of 0 and 3? 1.5. So isn't that just 3 pi over 2? So we know we're going to have an intercept at 3 pi over 2. What's the middle of 3 pi and 6? So what's 3 plus 6? 9, and 9 divided by 2 is 4.5. So 4.5 pi or 9 pi over 2. Are you guys okay with that? So we will have an intercept there. This would be negative 3 pi over 2. Okay? You guys okay with that? Now we have to split these parts in the middle. To find r, then we'll use our amplitude, correct? All right. So what is the middle of 1 or 0 and 1 1/2? What is the middle of 0 and 1 1/2? So 0 plus 1.5 is 1.5. What's the middle of 1.5? 0.75, right? Which is 3 over 4, or 3/4, 3 pi over 4. I can't even talk. Okay, sorry. What's the middle? So what's 1 1/2 plus 3? 4.5. What's the middle of 4.5? Divide that by 2. What's 4.5 divided by 2? Huh? 2 1/4. Yeah. So 2 1/4, isn't that 9 pi over 4? Yeah. Okay. So can you guys keep finding that pattern between those two? Okay. Now let's actually figure this out. We can either A, use our calculator, or B, we can just figure it out, right? Look at our amplitude. Okay. Now, if you notice with our cotangent, we decrease from left to right. So we know at 3 pi over 4, we're going to have somewhere up here, right? It's going to be a positive number. What is my amplitude? 2. So we're going to have at 2. So then at 9 pi over 4, we'll be at -2. There you go. So here we'd be at 2. Here we'd be at -2. Here would be at 2. Here would be at -2. And the main thing, guys, if you can get at least one of the markings here and then the other ones, just find the exact middle and space it out. I'm okay. You don't really need to write those in. I know exactly what you're doing. Okay. All right. Any questions with tangent and cotangent? You see how it changes where our period is from, where our vertical asymptotes are? Okay. I think cotangent is actually easier because you're doing from 0 to your period. Okay. All right, now let's look at cosecant and secant. Okay. If you notice, okay, tangent, we know the tangent function is sine over cosine, right? Secant is 1 over cosine. Because this is our cosines in the denominator, we know we're going to have a vertical asymptote again, right? And our vertical asymptote is whenever cosine of x equals what? 0. And when does the cosine of x equal 0? At pi over 2. So pi over 2 plus n times pi. Okay. For our cotangent is cosine over sine, which is the same thing as our cosecant, right? 1 over sine. So in that case, we will have a vertical asymptote when our sine is equal to 0. And when is sine equal to 0? At 0, at pi, at all that. So x would equal n times pi. Now, honestly, when we're doing secant and cosecant, I graph the sine curves first, and then I graph the secant and cosecants, okay? So we'll refresh this, yeah. N times pi. Oh, paper, sorry. Okay. So here is what our cosecant graph looks like, okay? Here is my sine function. Okay, so this is my sine function. Oops, I can't draw. So that's sine, right? Sine of x. For sine of x is, remember, it goes through the origin, it goes up, it goes down, and then it goes back to the x axis, right? Okay, so one period is always from 0 to 2 pi, correct? Okay. Now, with our cosecant here, our cosecant is in between our vertical asymptotes, which is where our sine is equal to 0. So we have that vertical asymptote at the y-axis, at pi, and at 2 pi. And then our cosecant graph is actually a parabola above or below each max or min. So the main thing I want us to do is, can we graph the sine curve? And then once we graph the sine curve, can we put our parabolas between our vertical asymptotes? That's all I want you guys to do, okay? So with these, what is the period of a cosecant curve? We're looking at cosecant. What is the period of a sine curve? 2 pi. So cosecant is still 2 pi. But again, we might have to take 2 pi and divide it by b, okay? If we have something being multiplied by x. Is my domain all real numbers? No, because don't we have those vertical asymptotes? Yep. And our vertical asymptotes, so it's all except, where are my vertical asymptotes again? At pi, so n times pi. Look at my cosecant graphs. Do we include every number on the y-axis? No. What numbers don't we include? We don't include the ones between our maximum and my minimum, right? Okay. Our cosecant is always above or below my sine curve, right? The max of my sine and the min of my sine. So the range is actually going to go from negative infinity to -1, and then +1 to positive infinity. Now, if my amplitude changes, this -1 and 1 will change, won't it? Because if my amplitude goes to 3, now my sine curve is maxed between a -3 and a +3. So now my range would go negative infinity to -3, +3 to infinity. Okay. We have vertical asymptotes at x equals n times pi. So 0, pi, 2 pi, 3 pi, 4 pi, and so on. Do we have any x-intercepts? Nope. Do we have any y-intercepts? Nope. What do you think we're symmetric on this one? Huh? It's actually the origin again. Yeah. And once again, it is a odd function. All right. Secant goes off of my cosine. What's different on my cosine and my sine curves? Remember, our secant or our cosine starts at 0 and goes down, right? And up. Okay. So instead of going through the origin and then going up to our max, we start at our maximum and then goes down, right? So in this case, our vertical asymptotes aren't at 0 and pi, they're at pi over 2, 3 pi over 2, 4 pi over 2, negative pi over 2, okay? And then our secant is just above and in between those vertical asymptotes. So it's just kind of being shifted over, okay? So again, what is the period of a cosine curve? 2 pi. So again, we might have to find it by taking 2 pi divided by b. Now my domain is going to be all reals except x can't equal what? Where do we have our vertical asymptotes? When my cosine is 0, which is pi over 2 plus n times pi, because you always add pi units after pi over 2, right? And then my range, again, we can't include numbers between what? -1 and +1. Or again, if my amplitude changes, it will stretch it out, right? Vertical asymptote, x equals pi over 2 plus n times pi. Now, do we have an x-intercept for this one? No. But do we have a y-intercept? Yes, because my cosine goes through the y-axis, right? And where does my cosine go through? 0, 1, whatever my amplitude is, right? Now, what is this one symmetric over? What do you think? Think of a parabola. What is a parabola symmetric over? Y-axis. Because, and the reason being is because of this parabola right here. The left side is exactly like the right side, right? And this one is an even function. So if I plug in a negative value, we get back to its original value. Okay, so secant of x is the same thing as secant of negative x. Okay. So let's go ahead and sketch the graph of 2 cosecant of x plus pi over 4. So again, what I want us to do is I want us to graph the sine function first. So can we graph the function of y equals 2 sine of x plus pi over 4? Can we graph that from last class? Yes, let's go ahead and graph that. Okay, so let's think about this. What's my amplitude of my sine curve? 2. So we know we have a max at 2 and we have a min at 2, right? What is my period? 2 pi. Why is it 2 pi? Because the sine is always 2 pi. Okay, because it goes from 0, 0, 0, all the way to get to 1 rotation to 2 pi. Okay, because we got to go up and we got to go down. Huh? The b, what's in front of x? What's the number being multiplied? 1. So 2 pi divided by 1 is still 2 pi. So we want to write that in. We can. No. Okay. Now, what does that pi over 4 tell my graph? It shifts it to the left, right? H always lies, right? So instead of normally in a sine curve, don't we go through 0, 0? But we have to shift it left pi over 4, right? So if I'm originally at, let's just kind of do it this way. Normally I'm at 0. So if I subtract the pi over 4 over, that puts me at negative 4 pi. Negative pi over 4. I can't even talk. Okay. So guess what? At negative pi over 4, we're going to have an intercept of 0, 0, right? For my sine curve. Right? So we have, my first coordinate is negative pi over 4 comma 0 in a sine curve because that's an intercept, correct? Okay. Now, I'm going to go ahead with that intercept. I'm going to go ahead and draw in a vertical asymptote. Because guess what? Because at negative pi over 4, my sine is 0, can I divide by 0? So I know wherever we have an x-intercept, we actually have a vertical asymptote in our cosecant graph, okay? So now let's go ahead and look at our final point. What is my technical period? 2 pi, right? So normally it goes from 0 to 2 pi. But we have to shift that to the left, pi over 4, right? So how do I move pi over 4 to the other side? Subtract it, right? So what is 2 pi minus pi over 4? Isn't that 7 pi over 4? Yeah. So to the right at 7 pi over 4, this is where we will finish our sine curve. So guess what? We are also going to have a vertical asymptote there. Okay. Does that make sense to you guys? Now, remember, with our sine curve, we go up, we go down, and then we hit our final. So directly in the middle of these 2 points, won't we have another intercept? Directly in the middle? Yeah, where is the middle of negative pi over 4 and 7 pi over 4? What is the direct middle of negative 1/4 and 7/4? 3 over 4. Yep, so 3 pi over 4. I like always get rid of pi when I'm trying to find middle. Okay, is everyone okay with that so far? Now, let's go ahead and keep working. Now, in the middle of negative pi over 4 and 3 pi over 4, we will have a maximum, right? You guys okay with that? And between 3 pi over 4 and 7 pi over 4, won't we have a minimum? So let's go ahead and find those values. What is the middle of negative 1/4 and 3/4? What is the middle of 3/4 and negative 1/4? Is that 2/4? And what's 2/4? Huh? Pi over 2, right? Okay. What's the middle of 3/4 and 7/4? 10/4, which is 3 pi over 2. So here is my sine curve, just one period of my sine curve. So guess what? Once you have that, guys, you can make your cosecant. Why? Because it's just the parabola off of your minimum and your maximum. And they just stay in between each one of those vertical asymptotes. And I don't care about finding more points in between that. As long as you guys, if you can graph the sine curve exactly right, and then draw your parabola above and below that. Because obviously we know directly in the middle of those, it's going to be, give me another point up there that's greater than 2 or less than 2. No, less than negative 2. Okay. Now, could we keep going out and extend this farther if we want? We know the next one over here would be up here, right? This one would be down here and so on. Okay, you guys okay with that? All right. All right. And then our last one, this is where we're going to finish up. Let's do secant. Secant is the opposite of what? Cosine. So can we graph the cosine of 2x? Yeah. What is my amplitude? 1. So we know our max is going to be 1. Our min is going to be negative 1. Okay. So now, what is my period? 2 pi divided by b, and what's my b? 2. So it's just going to be pi. Okay. So if I look at that, all right, so we know it's going to be pi. Now, here's my question. We know our cosine always starts where? Does it start at the origin? Or does it start up at the amplitude, the max, right? So we start up here. Okay, and we need to take that out to what? Pi, right? Would be a period. Now, if I go out to pi, where is pi going to give me? Is pi going to give me a max or a min? Or an intercept? It will give me a max, won't it? That's not even, but that's B1. Because remember, our cosine goes down and back up, correct? Okay. So then directly in the middle of that, where would that put me? Pi over 2. Would that give me a max or a min? It'd give me a min value, correct? You guys okay with that? Then in between each one of those give me my intercepts. You guys okay with that? Now, where is my first intercept? Pi over 4. And where's my second intercept? 3 pi over 4. So because those are intercepts, aren't those my vertical asymptotes? You guys okay with that? So then if I go backwards, negative pi over 4, isn't that an intercept here? So won't I have a vertical asymptote? Then at negative pi over 2, I would have a minimum. At negative 3 pi over 4, I'd have an intercept. So I'd have a vertical asymptote. And then at negative pi, I would again have a maximum. Are you guys okay with that curve? Now, if this was just a normal cosine curve, would I have those intercepts or those vertical asymptotes? No, okay? Now, once I have my cosine here, can I draw my secant? Yeah, my secant goes in between the asymptotes, and we always have our parabolas with our max and our mins. There you go. And there's your secant.